I will meet you at these. ये सर लेकिन इसमें वो डीप लर्निंग टूल बॉक्स
पॉइंटर यूज करूंगा नहीं चाहिए सिर्फ पॉइंटर चाहिए हम्म
Now this is the fourth day of ATAL Academy. It is sponsored by the AICTE, and this is the session and practical session. So you will explain how to implement the deep learning model, which is a part of the artificial intelligence, so you can say the machine learning, right? To classify and detect the power quality disturbance. So here directly he will explain the image, like sinusoidal or non-sinusoidal. Then with the help of neural network, how directly we can detect the problem in the system. So here we are talking about the power. Similarly, if we are you may be aware about it, kind of image processing. So if any image is there, you can train your neural network and find out what is the problem. Like in some of medical, if you have a X-ray and other things, so then also can be identified what is inside in there. So there is a lot of use of the image processing in the medical science also. They are detecting hiding cancers, tumors, and other things. With the help of it is identified. So you have the original way. You can compare the disturbances with the original wave and you can identify the problem. Right? So suppose that voltage, normal voltage is how much? 220. And if swell is there, voltage is coming 300. How can compare the different network? It will take the neutral wave and impose the coming wave. So if there is a voltage up or down, identify there is a variation between more than the specified limit. What problem is there? So there are two ways. In the previous session they discussed how to develop the code to identify the problem, power quality problem here. Directly he will show if image is there then how to classify for what kind of problem it is, right? So I will be there and we have with us Mr. M. Venkata Silva. He is working as a research scholar in the power system specialized are here, he will explain. If there will be doubt, we both will try to resolve it. Okay. So thank you very much, Dr. Shukla. Now you can, Mr. Shukla, you can start.
So, good morning, everyone. Myself, Srikar, and I am MTech second year student and working under the guidance of Dr. Jain sir. And today we are going to see power quality disturbance classification using artificial intelligence, which is session 2, which is continued from previous session in which Amitabh has already discussed it regarding how to do the same classification using you are using ANN, and in which initially you will be using a DSP technique for analysis, from which you will extract the features, and from the extracted features you are going to select the features and use ANN and do the classification. But without using this entire three sets of different procedures, you can directly use the same using deep learning. How to do that we will see in this session. Okay. And coming to the introduction, you already know from the previous sessions, many sessions they have discussed regarding power quality disturbances, what are different type of disturbances, and what is the need for the classification of the disturbances. Okay. And for for the same we need to use an AI procedure for this classification, in which we will see in this session. And artificial intelligence is a part of machine learning, and deep learning is another subset of machine learning, in which it uses an ANN. And artificial neural network I have already introduced. In deep learning, it has automatic. So by adding those things, it has automatic feature extraction and selection. And last time someone asked the regarding the software frame networks, which are TensorFlow, Torch, PyTorch, and CAF. Excluding MATLAB, there are also other software platforms which support Python and C++, in which you can do the same coding. And simply ANN versus DLL I have shown in this simple figure. See, in regarding ANN, if there is input, we need to do the manually feature extraction and feature selection. In Amitabh's thing, he has shown one DSP technique, in which he used DSP technique to extract some features, and from extracted features he used some features selection procedure, from which he selected some useful features for that, for his problem. And for after getting the useful features, he used the classification using ANN. Okay. Yeah. After classification, after extracting the features and selection, he used the classification using ANN. Then you will get result. But for deep neural network, there is no need for our manual feature extraction, feature selection. It will automatically do feature extraction and feature selection. Anyway, it will do the classification. Okay. And different types of activation functions, the same what are the same set of activation functions are required for ANN, same will be used for deep learning also. But
Here I would like to interrupt so that
yes,
here feature means the neural network. If you want to solve any problem, suppose x1 plus x2 is equal to y. So getting the output y, what are the inputs x1 and y? If you will change the value of x1 and x2, output will be same. So here for training the neural network, how neural network trains? It trains by the pattern. This is like kid. He doesn't do any mathematical calculation, no expression, nothing. If you will show, okay, and suppose what is this? So how it will understand? You will show him now. This is y. So it will understand. There is no mathematics. By just passing through the thing across the eyes of the kid, he will understand. In future, once he will ask, now he will ask different kind of what is this? He will say this is a mobile. Then he will explain what is the use of this. So whatever training you will give directly, you can later on iterate to what is this. Similarly, neural network also it learns from the pattern. So it is required the input as well as output for the training only. Testing it. There are two things, training and testing. So while developing the neural network, there is need to train the neural network by showing input as well as output. So it will learn. If x1 is 1 and x2 is 1, then y will be 2. If x1 is 3, y1 is 5, x2 is 5, y will be 8. So like it will learn. No calculation. X1 this, x2 this, y will be this. X2 this, x1 this, x2 this, y will be this. So if we will show x1 value varying from 1 to 1000, x2 value varying from 1 to 1000, y will be output it will learn. Now during the testing, there is no need to give the output. Just you will put the input, it will get the answer. Because now it is trained. But what range? If x1 and x2 will vary between 1 to 1000. बच्चे कैसे होता है ना बच्चों को जो दिखाओगे वही बोलेगा कोई नई चीज दिखाओगे तो फिर उसको ट्रेन करना पड़ेगा उसको नहीं पता है क्या similarly so here this neural network will be trained just by showing the picture ये देखो यहाँ पिक्चर से ना ये
Yes.
शो ऐसी इमेज होती है क्या चीज सेकंडरी मीनिंग जैसे मैं निकला अच्छा ये बच्चा निकला ये कोई गर्ल निकली कोई गर्ल है तो आप पिक्चर्स दिखा दोगे फिर आप उसी टाइप की कोई चीज निकलेगी तो वो पकड़ा जाएगा कि ये बॉय है कि गर्ल है ट्रेनिंग so here it will directly giving by the showing the pictures to training तब वाले केस में क्या था वो डेटा से ट्रेन कर रहा है यहाँ पे पिक्चर से और now these days you can convert the picture into data also क्या करना है कंप्यूटर में जाता है पिक्चर थोड़ी जाती है जाता तो डेटा ही है so you can convert by picture extraction using the DSP technique. So this is the simplest way. There may be some problem you will tell, but directly show the different kind of picture. Like learning if any kind of picture matching with this area will pass. Then I will tell what is this problem. Now do it. So now you understood the background.
And learning strategies are also similar to the ANN, in which there are three types of learning, which are unsupervised learning, supervised learning, and reinforcement learning. Generally in deep learning we will only use supervised learning, and combined with reinforcement learning it is generally called transfer learning. Means generally we will be having a deep learning model which is already trained, and we will retrain it using fewer samples, so that we can easily train the model. Because in deep learning the disadvantage is it will take lot of time to train, but if you are using large number of samples, again it will take more amount of time. So to reduce this kind of problems, the deep learning models were already trained, and using retraining we will train that deep learning model using supervised learning generally. And regarding back, for propagation generally or node. Okay, and here I have some simply this is an input and this is an output. Okay, when we are either training or testing, we will give the input to the system, and after processing that, we will get the output. But while training, we may not get the our required output. So we will exactly give what is the required output in form of transfer learning, and based on that, we will again compute backwards, and we will adjust these heads. Okay, this process is called as training with existing head, which is backward propagation method. The same thing we will use in learning only. What is this? This is like you are aware about the output. So output आपने किसको दिया 99. During the training, if the output is coming is the 95, the actual output requirement is कितना 99. Predicted output is how much 95. So there is a error of how much 3 errors. So that error should not be there. You can calculate the number of the thing. So there is a need to go back and adjust the bit so that error can be reduced. एक समय आएगा कि क्या होगा 99 actual Yeah, from input to the output, it is normal working of the system, and when it is coming back to adjust the weights, this procedure is called back propagation, in which we will give the desired output. So this is generally done in the time of training, and this desired output which we are giving in MATLAB, it is called validation input. Okay, and for this the flowchart is almost same as Amitabh one, but the thing is, after mathematical modeling of PQs, we will generate images, and the after image generation, we will rescale the image as per our model requirement. In deep learning model, there are different set of models for deep learning, in which the image input, whatever we are going to give input to that model, is of the different sizes. So depending on the model requirement of the image size, we are going to rescale the image, and we will give that image to the input for training and validation. And after, once the deep learning model trains, we will get a trained model for which we will give the input, and we will get the desired output. Hmm. MCQ. हाँ. Now let's have some hands-on experience how it works actually in MATLAB. See, in MATLAB, if you go to apps, there will be uh, in machine learning and deep learning, there is deep network designer. If you click on this deep network designer, the deep network designer apps opens as shown. Okay, first it will be there won't be any model here. If you go to new, see, you can already load some pre-trained models which are SqueezeNet, GoogleNet, ResNet. These are all pre-trained models which are already available with MATLAB. Deep learning models. Okay, and here I am using SqueezeNet model here. Open. This is the SqueezeNet model, in which it has 68 layers and it is 18 layer deep. Okay, and see here you can see the input, which is input image layer. Here you can see the size 227 227 3. So one is height and width. What is the third dimension in image? Anyone can say what is the third dimension of the image? First two are width and height, okay? And what is the third dimension of image? Have you any idea regarding that image? If you are interested in image processing, you may have the idea. What is the third dimension of the image? Any idea? The third dimension is color channel. Means how many colors it is using. Generally, it will be 3 or 5. But in MATLAB, whatever we are using models, we are using only 3 channel input, which is RGB, red, green, and black. And these are different types of uh, blocks which we can drag and we can use it in while designing. Already I have taken a pre-trained model, but if you are going to design a new model, you can use these two toolbox here available to design the model, in which this is the second layer is convolution layer, in which there will be particular size of filter. The filter will always scale over our current image, and it will extract features. I have already told you in the PPT. See, in the PPT for deep learning, it deep learning is a class of machine learning. The higher level of concepts are defined from lower level ones. See, first it will extract the lower level features, and using that lower level features, it will always extract higher level features from low level to high level. While predicting, it can predict from high level to low level. Okay. And uh, to I said that when there are many hidden layers, there will be a problem of saturation when using non-linear activation functions. To avoid that saturation problem, we are going to use this max pooling one, in which it will group the same kind of things, and from that it will extract the relevant samples from the from the samples inside. And apart from max pooling, we will also use for fire relay one. Generally max pooling is used, and there is also one more one, dropout. Max pooling is used to extract the relevant features, and dropout is used to separate the unwanted features. These two are used so that the saturation problem can be overcome when there are many different hidden layers. So, 68 layers, but it is 18 layer deep. Here, every block is considered a layer in the deep learning model, and every node is considered as a hidden layer. So, number of hidden layers are number of layers depth of that model. And generally, these are the pre-trained models, and in any pre-trained model, there will be a last set of convolution or fully connected layers. This thing, convolution and fully connected layers. In last set, you can see here there are number of filters are 1,000 here. See, means it is uh, pre-trained to select 1,000 number of different classes. But here I am only having 4 classes, so I will remove this layer here and add a new layer here. Okay, in new layer, and my classes are only 4 classes which I am going to classify. And filter I will keep minimum so that I can get maximum uh, resolution. And regarding learning, last learning rate should be higher than initial learning rate. So I am going to keep bias learn factor and weight learn factor around 10. Okay, and connect it. Okay. And classification is already output size is 1,000, but here I need only 4, so I'll delete this and I'll add new classification here. Okay. And after doing this, if our model is correct or not, we can always analyze whether our design is correct or not. Let me analyze whether this model whatever I have designed is correct or not. if there is any error, if inputs and outputs are not matching, if the number of classes are not matching, it will always show. And it we can directly we can adjust after knowing the what type of error and where it is occurring. See, there are no errors. Okay, and now the model is ready for us, but for to give the image input, we need to give images from here. For that, we will first generate the images. Okay, see, for voltage interruption, I am same the whatever the code Amitabh has used, I am going to use the same code, but I am plotting that image and I am saving the image is the additional thing. Okay, I am starting the program, and see, you can see the image will get saved in this column.
Generate. ले सकता है लेकिन लैब में तो नहीं दे सकते generated by making it mathematical generation of
And see, while generally you are plotting in MATLAB, this plot will be maximum size, right? But see, I have only taken a small plot here. Can anyone tell why I have taken such a small plot over here? I have not used this total window. Only I have used the small window over here. And for that, I have to write additional set of code also in the program. See, T1 equals to title layout, and I have given the size of that in inches. Can anyone tell why I have done so? See, in this, I have already told we need to do image rescaling. While image rescaling, if the size of image is larger, and when we are scaling the image to a smaller image, large amount of set of data will get wasted. So instead of wasting that set of data and not finding that data, I am initially taking my image closer to the original size of the image. I can't take the exact size here, so I'm taking the image closer to the original size. Then I will rescale, and a very small amount of data will be lost while doing the rescale. It is important that when you are using any neural networks, using images, you select an image which is almost nearer to the scale in which you are going to do the classification. Or else, when you are reselling directly in MATLAB, if you are reselling you using other softwares, I am not sure, but in MATLAB, most amount of data is lost because MATLAB is matrix laboratory. It will use always anything in the form of matrices. Okay, a large amount of matrix it can't convert to small matrix directly. It will leave some data so that it can convert large size to smaller size. So I'm using this smaller size one so that I can easily get my required output. Okay, I have generated. See how many images I have generated. 99, 100, 110 images I have generated. Okay, 110 images I have generated here.
training data is required. If you have more training, then the your system
Okay, and voltage interruption I have see I have generated 110 images, and normal also I will generate.
there are almost 16 types of power quality issues. There will need to generate all type of images so that the network can understand what kind of power issue. that, once you develop a model, if you say anything that will come, it will catch and identify. There is a possibility one signal, three, four, five type of disturbances may happen. One single check हो सकता है, कंपोज हो सकता है, value भी हो सकता है, note भी हो सकता है, anything may be there. So there may be combination of such disturbances also. So you have to show each and every kind of image to the user. उसके बाद उसको समझ में आया, कुछ भी आया, so that you can catch, right? So he is generating how many types of four. So then it can capture out of those four only. क्योंकि आपने ट्रेनिंग ही चाल कर दिया है तो वो कैसे लेकिन यदि केवल पास तक सीखा तो इट विल वेरी डिफिकल्ट टू टेल द हैविंग टेबल ऑफ दैट एक बार आपका ट्रेनिंग हो जाएगा then you can if you are trying for the 20 table of 20 then you can even put in 21 also. So initially good training is
Huh? Yes, MATLAB, anything is regarding matrices. Images are also, it will read in the form of matrices. Yes, exactly.
compared to the normal like 1%. It will vary between 0.9 to 1 point. Anything will go below that or beyond that, it will predict what is part of it. But you have trend like this. You are trending one.
See, apart from you are copying the same image and pasting, then only you will get same values. No two images will be the same. Even they may look similar, but they will never be same. Same in your case of project also. If you are doing plagiarism check, if you are generating your own images, even if it looks the same, it will not say it is plagiarism because you are generating your own image. Never two images will be the same. Okay. I have generated for voltage interruption and normal, then I will generate for sag.
And this is like natural phenomenon. Human is sick. Even there may be resemblance, but 100% there will
Same,
be.
it will never be. Apart from you are copying and pasting the same image. So direct comparison, no one will do in math because it will never be same. But neural network, you can train it. If the two images are same, then it will show there are two images. See, if you are having already data, you can load it into MATLAB and plot it, and you can save it as image. Generally, from different outside sources, we are going to get sampled data. See here, I am using this sampling frequency, same Amitabh we has used, right? 3.2 kilohertz. The same sample frequency. If you are unable to see, see now you can see sampling frequency I have used 3.2 kilohertz. Generally for sampling frequency, I don't know whether Amitabh has introduced or not. We are using, they will use sampling frequency of 3.2 kilohertz. Practically.
15 means what I want to if you are talking about is if you want to capture up to 15 then you
Yes.
60 Hertz case. If 60 Hertz case, then it would be different.
Yeah,
If you want to go up to 30, then you calculate like this. Similarly, you can calculate if you want to go up to 100, then you can calculate.
Yes,
Like that.
but practically whatever power quality analysis you having hardware thing, they'll be using up to 3.2 kilohertz
That is something.
sampling
That
rate.
is okay. That is not practical. That is
Classification, only classification.
it will give the it will give. Harmonic distortion is classified. It is just doing the classification what kind of power quality issue in the system. So just after taking the image,
In
it
an
will classify whether voltage gospel or harmonics or interharmonics or oscillatory harmonic, what is there. So then we can classify. Accordingly, the person can take the decision.
Vinay, see, Vinay. Generally, in an overall view, if it is harmonic disturbance or other type of disturbance, one deep learning model can classify. If it is harmonic disturbance, give the same signal to another deep learning model in which it will again classify what are the different types of harmonics in are occurring in the harmonic disturbance. Yes, used to.
Value, I think you can
Yes, we can calculate deep learning model.
providing some mathematical.
Yes, we will provide the mathematical formula to that, and it will know, and based on that, it will calculate what type of harmonics are occurring in the signal. It will be another dedicated one. So there will be two deep learning models which will be interconnected. Only for harmonics, if you are going to classify inbuilt, because harmonics also there are many cases and different types of structures. If you are giving everything to the original one, it will have many classes and it will take too much time. So better than that, you give general harmonics case for this, and after that, based on the result, you analyze whatever the harmonics are coming in another model. Okay. So I have generated 100 images, 110 images for all these things. Now after generating the images, what I'm going to use SqueezeNet, so I'm going to resize the images. See? And input size is 227 here. See, this input size I came to know from the network designer. I have already shown, right, in the image input layer it is 227 by 227. Okay, the same thing I have given, and I am going to resize. I am resize. Okay, and I am going to resize all these images into required format from 1 to 110. If it is resizing or not, you can go to folder and you can see. SpaceNet. See, resizing 90, 91, 96, 100, 110. It has resized all images. These are resized images. Okay, now image has been resized. So what I'm going to do is in this, after resizing images for testing purpose, I will take out some random 10 samples from every case. One. Okay, some random 10 samples I have selected. I'm going to remove them. Voltage interruption I have selected, and voltage normal also I will select some samples. Randomly I'm selecting. There is no required thing. Randomly you select. 10 samples I have selected. From cells, well also I will select random 10 samples. Selecting for testing, sir. Testing, I am removing these samples from training samples. These samples will be used for testing.
Already provided the training.
No, no, I will provide the training. So I have removed these samples.
Now we can image.
Yes.
And yes, out of 100, how many selected? And 10, 10.
10, 10, 10.
10,
10 percentage.
and 10. So first they will use the training.
General.
वो 10 जो उसने नहीं देखा पहले those 10 whether it can protect चलेगा
Generally, for accurate training and for good testing, you will take the test samples as 10 percentage of total samples. So I have taken 100, 10 percentage is 10. So I am using those 10 images for testing.
उससे learning नहीं होगा
Yeah.
out ही हो गया उससे नहीं होगा
So see here.
This is the algorithm. So where you can run the algorithm. Suppose that the original data is coming through the hardware. Inside there will be some calculation and inside there is a code only.
In hardware, regarding hardware, the deep learning models were already implemented using FPGA platform. FPGA platform is already implemented. It has to be verified, implemented, and done. Okay. Hardware whatever you need to do is after taking the uh, sampling data, how to feed that sample data in form of images to the given FPGA model. That will be your hardware requirement, not FPGA model for deep learning. It's already there for FPGA model regarding deep learning. Only the interface from power system to this FPGA model, the interface model. Ah. See, here you can see export and generate code. Whatever you are having, you can generate code for this model that directly into the MATLAB. Yes. Now I am giving the input data, which is training data.
Training is started.
And see, training is divided into two types: training and validation. Okay. First, I will give you training data.
There are two terms. One is the training and validation.
Yes.
It's like that. Let's suppose that I am taking a class. At the end of class, I will give you one question. That is a validation के बाद ही होगा. तो इसमें क्या होगा? ट्रेनिंग के दौरान ही वैलिडेशन कर रहा है. तो उसमें आपका जो एक्चुअल से कंपेयर करेगा कि यार ट्रेनिंग हुआ तो ठीक हुआ.
Yeah, we will
Final
give
testing will be the end result. वो अलग होगा.
For training, and this is for validation. For training, it will go from here to here, and for validation, it will come here to here. Yes, feedback. So training data, we are going to select this folder. Okay, and here it will ask, see, in validation training data, but you can directly split from the data source itself, or else if you are differentiating two different sets of data into different folders, you can also specify the folder. Here I am just splitting from the training data itself, 30%. So 100%, 30% means 70 and 30, right? See, I will show you 30% here, import, and class labels will be the folder names. See, class labels will be the folder names, and the size of number of images will be 70 for training data. Same you can see for validation also, 30 samples for validation, training and validation. Okay, and some random samples also you can see. Random samples.
Different images, not normal
Different random samples you can see here. Okay, now for training. In training, you training options. I have already told you learning rate. Initial learning rate should be very less, and final learning rate should be more. So initial learning rate, default learning rate is 0.01. This is for large data sets. We are not going that much large data sets, so we need to keep very small learning rate. Okay, and validation frequency. Validation frequency will be done for one approach. Here I am using 4 classes, so one approach consists of 4 iterations. So validation frequency should be 4. Maximum number of approaches 30. It is fine. Minimum batch size. See, minimum batch size is number of training data images, which are 70 here. Remaining things are default values. No need to change them. And after that, you need to click on train. Now, while it is training, I will make this testing samples. Okay, interruption. Okay, these are an interruption. Normal. Normal.
images.
No, sir. It will take another 15 or 20 minutes. In between, I'm sorting out the samples. This because I'm using program to check all samples at once. The name should be in an alphabetical order or ascending order, so that I'm naming voltage interruption 1 to 10. I'll name again then, because I have taken random samples here. I'm renaming every sample here. Simply. See, it has already reached the final iteration now. The model has already reached the final iteration, and out of 30 approaches, there will be 4 iterations per approach, and number of total iterations will be 120. 4 into 30, 120. Okay, and after training that, you export this model, export the train network and results. So this train network and result will be exported into the MATLAB. Here you can see this is the our required 1x1 DAG network model. This network model you are going to save. Okay, save as. Okay, after saving that, we are going for testing. Testing program is quite simple, in which we will initially load that pre-trained model whatever we have obtained. Okay, and after loading the model, we are going to read one image, and we will feed that image, and we will classify that image using this inbuilt function of classify. Okay, see, I have given here image voltage normal, so output should be voltage normal for me if it is accurately testing it. Let us see whether it is accurately testing or not. The given image is a voltage normal disturbance having probability of 0.996. So it is accurately predicting it is voltage normal. This is for in case of single images. If I am giving combinedly 10 images as per one class, I have written another program in which it will directly show how many images it is belonging to a class, and how many it is accurately classifying, and how many are not accurately classifying. We will see this program also now. See, voltage normal is accurately out of the 10 images, and error is 0. Same for everything. Done classification. Because see here, accuracy itself is going for 100 percentage, so it is accurately classifying whatever images are required. From this we can do that classification like this, in this way. सर classification हो गया सर? हाँ ठीक है सर. ये सिंगल इमेज का है सर. सिंगल इमेज में अभी मैंने इधर देखो सर, इमेज रीड में in image read FTP2 SqueezeNet testing voltage normal and voltage normal. I have given some normal voltage to it. I'm just initially testing for single image. Okay, and it should give me the answer of the image is having the given image is of so and so disturbance. Here it should show in so and so, it should show voltage normal. So I'm going to run this program now. The given image is of voltage normal disturbance. It has shown. Yeah. Voltage normal. Yes, sir. Even if you can write label, see in the label it will store the answer. Voltage normal. Huh. Disturbance, yes, yes. Yeah, yes. We'll see testing. We'll go for SAG. given image is a voltage sag disturbance. And this is regarding single image. But if you are inputting all set of images and you are going to get the resultant output, you can also see that in case of this program. So regarding all voltage normal interruption sag and 12, we have given 10 input image. It is accurately detecting 10, not accurately 0. Because here while training itself we got error of final accuracy of 100 percentage.
You can see. Now you see it's over.
His computer is working very fast. It only took 2 minutes to train.
Right. So thank you very much, Mr. Srikanth. And if you have any query, you can ask, right? And it's the after T and double 11:45. We will again assemble here. There will be one lecture. Probably 15 minutes and I will very much call the others also. Right? Why they are not here right now? We have the regular classes. After completion of any query,
Yes. ऑनलाइन स्ट्रीमिंग वाला करना है। भाई इसको भैया